Saxon Algebra 2, Lesson 82. We're going to bump ahead another step in our work on complex fractions, you know, where there's a bunch of division bars. Those are kind of crazy, aren't they? We're going to work on those, but before we do that, we're going to take a minute to just review the 3 rules of algebra. I know, seems like there's a lot more than just 3, right? But these are the 3 basic rules of algebra that make the whole thing work, all right? The first 2 are about equations. And remember, the easy way to tell if you have an equation or not is you look for an equal sign. Okay, the first rule is that you can add or subtract the same quantity to both sides. Right? And we do that all the time. We call it swimming fish, right? You can move the numbers back and forth across the equal sign. All right, so that's easy. The other one is that we can multiply or divide the same quantity, except it can't be 0. Multiplying by 0 or dividing by 0 is not allowed. Dividing by 0, we know that blows up the universe, right? So you can do any other number to both sides. So it's the same rule as the adding and subtracting, right? We can add or subtract any number. We can multiply or divide any number except 0, all right? So that's the caveat to the multiplying and dividing. Don't use 0, but anything else will work. These are the 2 rules that we use for equations. The third rule is for expressions. And we know that expressions are algebraic sentences, if you will, that do not have an equal sign. And P.S., our complex fractions are this category. They do not have equal signs. So this is the rule we'll be looking at today. And this rule, this is the third rule of algebra, is that you can multiply or divide the same quantity and I guess we should say non-zero again too, to the top and the bottom. We've been doing this since we first learned how to adjust fractions, right? If you want to take the fraction 1/2 and adjust it so that it has a 12 on the bottom, you would multiply it by 6 over 6, right? This is the third rule in action. We're multiplying the same quantity to the top and the bottom, right? That's an example of that. So we've been doing this for a long time. And when we work our complex fraction problems, which we're going to get to in just a hot minute, this is the rule that we're using again and again and again. So these 2 work for equations. This is the one that we use for expressions, no equal sign. And this is the one that we use with complex fractions. Just wanted to remind you that these 3 categories exist. Oh, it's my last piece of paper. Okay, so here we go. Example 82.1. How many examples are in this lesson? 2. I guess I better get back up in camera range here. I was floating away. Now, when you look at these problems, you'll gasp in horror. It says to simplify, but look at this hot mess. Are you joking me right now? We're supposed to simplify this. All right. The way that we start is we go down into the deepest, darkest corner of the basement. My grandma had a cool house. I loved her house. It wasn't big, but it was very interesting to me. And she had a basement where you came down like in one corner and then you could walk around the whole part of the basement. This was like divided. So you walked around like this and there were different rooms as you kept going around. And I always think about going down. It's one thing to go down to her basement, like this is the whole basement, but then I had to keep going to the deepest and darkest part of her basement, which is actually where we slept. Where you first came down, that's where she had all her canned food. She was a big canner. She grew a garden and had a bunch of food canned. And this was rife with spiders. This was her laundry corner. That was creepy in my mind. This was her big old furnace that looked like a robot monster. This was a corner where my grandpa had his model train set up, and then where we slept, there were bunk beds in this part. So I had to walk past all these scary things. The train didn't scare me. All of these parts in order to get to where I slept. That's what I always think of here. You're going to the deepest, darkest corner of your grandma's basement. And maybe it's not scary, but maybe it is. Okay, so we put our attention here first. Remember that our strategy is to smush, which means multiply top and bottom. So we can add. That is our first line of business. We want to smush. So I look down here and go, okay, these two guys are separate, so we need to smush them together. We need to multiply the top and bottom so they have matching denominators, because that's the only way you can add fractions. So I can see I need an x here, and so I make a little note. This is just a 1, so it's easy enough. I can change this into x over x, right? That's equal to 1, and now it matches. So now I can add this, and I get x plus 1 over x. All right, I'm going to draw a line through this to show that I've already dealt with it. Okay? So this is what we've got in our deepest, darkest corner now. Now we want to do the flip. The flip means multiply by the reciprocal. Top and bottom. To eliminate the denominator, because it'll turn it into a 1, right? So if we multiply this by x over x plus 1, this is going to turn into a 1, right? Because this cancels against that, and this cancels against that. And so this equals 1. Hallelujah, the 1 explodes. It pops like a bubble on a sunny summer day. And now this denominator has gone away. Not the whole thing, but we're making progress, right? However, we multiplied by the denominator here, and as I said, we have to multiply the reciprocal top and bottom. It did its job on the bottom, but in order to follow the third rule of algebra, we have to multiply it up here too. It's important that we stay focused on the fact that like this we're not dealing with. This is just the fraction right now, right? It was a over 1 plus x, and then we added the denominator and we multiplied by the reciprocal. So here is where we multiply the numerator of this little fraction. It's confusing because there's so much stuff. So now our problem, I'm gonna multiply these two together. This is over 1, if that helps you. So it's ax over x plus 1. But I'm gonna rewrite the whole problem. There's the big A. There's the 1. Whoops. There's the 1 plus, and now we have ax over x plus 1. We're making progress. Okay. So now we follow our rules again. We smush and flip again. Smush. These two have to be brought together. We have to add them so they're one fraction. So we have to multiply the top and bottom of one or both of them so that we can add. We find the LCM. It's x plus 1. So this, we just have to multiply times x plus 1 over x plus 1. We can see this is equal to 1, right? So we've successfully converted that. And now we're adding these. Let me recopy my plus sign so you can see it better. Now we can rewrite this denominator as, I'm going to put the numerator up there too. It is x plus 1 plus ax all over x plus 1. We have successfully smushed these two pieces of the denominator into 1. Now we're ready for the good old flip. Are you ready? I'm excited. Okay, so we're going to multiply it by x plus 1 plus ax over x plus 1. And then we have to do the same up here. I'm a little crowded for space, so I'm going to squish it in a little bit. X plus 1 plus ax over x plus 1. This, I wrote it wrong, didn't I? Because that's not the reciprocal. I wrote the same thing twice. Ooh, that's bad. No, no, no. Right? Because when I caught that because when I went to cancel, I realized that's not the right way. So let's erase all of this. Now, let's write the proper reciprocal. X plus 1 has to be on the top, and then this has to be on the bottom. Okay, I like that much better, don't you? Because now I can properly cancel that. But before I cancel it and chop it out, I'm going to write it. This time I'm going to write it over here. Normally I would put it here, but I made a mistake. So now it is x plus 1 over x plus 1 plus ax. And that is all being multiplied by a over 1. Now I have proper cancelage. Let this be a lesson to you, students. Make sure you cancel that because that will catch any mistakes. That's how I caught my mistake right there, is when I went to cancel, I said, oh dang, I did it wrong. Okay, and now all we have to do is multiply a over 1 times this, and we will leave the top undistributed, and we'll leave the bottom just the way it was. That's our final answer. If you looked in the solutions manual to check this problem yourself and you saw ax plus a, you would know, oh, John just distributed, I can easily make mine look like that, right? There aren't any hard and fast rules about whether to distribute or not to distribute. I generally like to distribute the numerator, but it's fine because John shows it like this. It's fine, we can live with that. No problem. Okay. Distribution is neither right nor wrong, it just is what it is. So we're going to take our rules of smushing and flipping. By the way, these are not mathematical terms. They were invented by a former student whose name's Evie Jones. She now works on a cattle ranch in Texas, which is pretty cool. But she came up with these words and I thought they were super useful and helpful. So let's try one more example. Look, it's the end of the notebook. 82.2. Here we go. Okay, we gotta go to Grandma's basement, got all the way down to the very bottom. Here it is, and we're gonna start with a smush. We see the denominator here is y, so we need to give this one a denominator of y. And then we have to multiply top by the same. So this becomes xy plus 1 over y. There's the smush. Now we do the flip. That's going to cancel nicely for me. So then I need to multiply this one by y over xy plus 1 as well. Okay, so that turned into that. This all cancels. Now I'm going to rewrite the whole thing, b over a plus, now it's cy over xy plus 1. Whew. We take a break, we breathe, we go, man, that's really hard. How do I know to do all that? You're smart, that's why. Okay, now we need to smush again. We need to get these two together. I'm gonna have to multiply by xy plus 1. So I'm gonna write it up here a little bit so it's easier to squish it in. And then we'll do bottom xy plus 1, right? We're allowed to do this. It's the third rule of algebra. And we're adding these. So that means we'll have a times the quantity xy plus 1 plus cy over xy plus 1. Lord have mercy, right? Now, the last thing we have to do is flip this and multiply by the reciprocal. It's going to be a lot. Are you ready? So the reciprocal, I'm going to write it down here because I don't have room to write it out here, but we're multiplying them together. It's going to be xy plus 1 over that's on the top, that's on the bottom, that's on the bottom, that's on the top. Okay, that's going to cancel beautifully. Now, up here, I need to carry this reciprocal up here so I can multiply the top as well. Okay, reciprocal, reciprocal. This all canceled. And now I just have to multiply this for my final answer. Let's write b times the quantity xy plus 1. Whenever we have addition in these, you can just start slapping parentheses on them. You cannot go wrong with those parentheses. b times the quantity xy plus 1 over a times the quantity xy plus 1 plus cy. Okay, that looks really good. I see there are two places where I could distribute. Again, I remind myself distributing is neither right nor wrong. It's just a question of how you want to play it out. And in order to check my answer with John, I want to make sure I've distributed if he distributes and not distributed if he doesn't distribute, right? I want my answer to look like his so I can just check. So I look at my answer in the book and I see, oh, he did not distribute on top, but he did on the bottom. Okay, dealer's choice, right? So let's make ours look just like his and see if we came out the same. So I'm going to distribute this. It would be AXY plus A, right? I do this. AXY plus A plus CY. And now I compare to his answer and I say, hot diggity. It's exactly the same. I don't know about you guys. Maybe you're immune to it because you've done so many homework problems. But I just get a little jolt of adrenaline when I see I got the problem right. That makes me so happy. Okay, smush and flip. That is the way we handle these complex fractions. Plus, we remember to always go down to the deepest, darkest corner of Grandma's basement before you start the work, right? Smush and flip. I'm going to write that down. Smush first, because we have to get them into one fraction before we can multiply by the reciprocal. Yay! That's the end of lesson 82. Thank you. Goodbye.